Okay, hi guys. Okay, today for this video we'll be dealing with EM waves. Okay, so let's start. Okay, I think EM waves is quite simple. Okay, but to start it all off, okay, I want to introduce us back to the electromagnetic spectrum. Okay, of course, when the word EM is mentioned, EM basically just refers to electromagnetic spectrum. Now, the one of the reason why I haven't really touch on what is the idea of EM wave is because I haven't really taught you all what is electric field and magnetic field. Okay, basically what I only taught you all was wave. Okay, and somehow EM electromagnetic happens to be part of the entity of waves. Okay, so yeah, so let's start off with the idea of EM spectrum. Now when we talk about EM waves, 7 main waves come into our mind straight away, and they are listed here: gamma ray, X-ray, ultraviolet ray, light, infrared, microwave, and radio waves. Okay, these are the 7 main waves that we are talking about when we say EM waves. Hence, when we talk about EM waves, we always link it with the idea of a spectrum. Now, the word spectrum means a variety or something. Okay, so there's a it's a range. Okay, so there's a range, say starting from gamma ray, okay, all the way to radio waves. So you know that including these two, there's still another 5 more in between. Okay, now one key thing to know that for gamma ray the wavelength is short, and for radio waves the wavelength is long. Now with this, I need you all to learn how to memorize the different values, okay, approximately. Okay, in case you're wondering, right, you can actually write this as 1 micrometer. Yeah, okay, because it's about there. All right, and the answer will be accepted. Okay, if you find 0.1 micrometer too hard to remember. Okay, now I'll come back to this picture in a while. Okay, but first let me go through this. So what is EM wave? They are waves consisting of an oscillating electric field perpendicular to an oscillating magnetic field. Okay, we'll go through this more when we touch chapter 20. Okay, so for now, let's just know that it's a transverse wave. Okay, and there are no particles that are oscillating. In fact, these are electric and magnetic field that are oscillating. So I'll just stop here for the moment, because this is really not in syllabus. All right. Yeah, we don't really need to, we can memorize this, okay, but there's no need to really understand. Okay, when we reach chapter 20 I'll explain this again. Okay, to be continued. All right, so right now we are at chapter 14. Okay, just 6 more to go. Okay, now but these 4 properties, let me label them as 1, 2, 3, and 4. These 4 properties, please go and memorize them. Okay, they transfer energy from one place to another. Okay, as with all waves transfer energy, right? Okay, they are transverse wave. Okay, that means they are perpendicular to direction, right? Okay, they travel through a vacuum with the same speed as the speed of light, which is 3 times 10 to the power 8, and they show wave properties like reflection and refraction, just like light. Okay, because light is EM wave, and therefore if light is EM wave and light behave in a certain manner, all EM wave must behave the same manner as light. Okay, now I want us to link this idea, this 3 times 10 to the power 8 here. So V equals to 3 times 10 to the power 8, right? Let me zoom this in. Okay, now so V equals to 3 times 10 to the power, hold on, sorry, 3 times 10 to the power 8 meter per second. Okay, now you remember that V equal F lambda. So let's say now that you have memorized that microwave is 1 cm as its wavelength, so lambda equal 1 cm, V equals to 3 times 10 power 8. Okay, 1 cm is also equals to 0.01 meter. Okay, whenever you do this question, please convert it to meter first. Now let's say I want to find what is the frequency of microwave, right? Okay, so frequency of microwave will then be V over lambda. okay, which actually gives us 3 times 10 to the power of 8 over 0.01. Okay, so that will be 3 times 10 to the power of 10 hertz. Okay, so I hope you all know how to do this. The shorter the wavelength, the higher the frequency. Okay, so while this is short wavelength, it will be high frequency, and if this is long wavelength, then this will be short frequency. Alright, okay, now let's move on to the next page. Now over here, basically I need you all to memorize this. Okay, of course, if you can, yeah, I mean, it's quite easily associated. Okay, other than the properties, right, the users should be pretty much common sense, I guess. Okay, so I'll just go through some difficult one. The approximate wavelength is in the diagram above, in this diagram. Okay, so you can, yeah, you can kind of just take a look at this column. Okay, if you memorize it, that'll be great. Okay, now for radio wave generated by high frequency electric current, I showed you the video before. I placed a video in the link again, so you all can watch it if you all want. Okay, now the users, TV and radio broadcasting, radio communication, of course, there's Wi-Fi too. Okay, now microwave produced by electronic devices. This is a klystron tube. Okay, so what is a klystron tube? Okay, it's also in the link below. Okay, so if you want it, please check it out. Okay, so cooking food is common. Okay, using microwave. This might be good to know. Okay, how microwave actually cooks food. Okay, I have also placed this in the link below, so please check it out. Okay, there's a lot of readings to be done, okay, in this chapter, so yeah, please be patient with it. Okay, infrared, visible light, UV ray, I mentioned in class. Now X-ray. Now X-ray will be interesting, okay, because these are the properties. Less penetrating than gamma ray, but it's one of the most penetrative ray that exists or that we know of. Okay, so yes, it's less penetrative than gamma ray, but it's penetrative in nature already. Now X-rays, photographs of bones and teeth. Now when we talk about X-ray of bones, right, in other words, it can actually penetrate through our flesh but not our bone. Okay, and that is one of the reasons why we don't use gamma ray to take a photo of our bones, because unlike gamma ray, which penetrates through our bone. Okay, so if we consider using gamma ray to take a photo of our bones, right, then yeah, I guess chances are it will actually destroy our bones. Okay, just like how X-ray can actually destroy cells. Okay, so I want you all to go and read the link I placed below. Okay, how okay, I want you all to go and read on this. It's also on the link, in the link below, how X-ray can actually destroy cells but helps fight cancer. Okay, now I think the rest, they are quite straightforward. Other than this word ionizing, the rest should be pretty much simple English to you all, right? I'll explain ionizing in a minute or two. Okay, so let me just talk more about X-ray. Okay, so X-ray has strong penetration. We talk about this. Okay, it's able to penetrate skin, body tissue. Okay, but it's not bone. All right. Okay, so there you go. Okay, so it's absorbed but not penetrated, or rather, but not being penetrated by it. Okay, and now gamma ray in nature just penetrates matter. It's used to kill cancerous cells in a worst case cancer patient. Okay, now when I talk about ionizing, this is what I meant when I say ionizing. Okay, they are able to remove electrons from the atoms of the matter. Okay, so basically if you have drawn your diagram properly in the waves, I already went through this. Okay, remember the shell, and then I say ionizing is when an electron is actually going to go out of this shell and in the process produces some form of light energy. Okay, so yeah, now it also affects the DNA by mutating it. So yeah, just some simple info. If I never remember wrongly, there's a code for DNA. So these four, they will be linked. So A and G, C and T. I also paste a link about DNA below. Okay, now in the case when X-ray actually comes in contact with the human body, right, the DNA might mutate. Okay, and if it mutates and link up A with A and C with T in this manner, this will cause a deformity. Yeah, you see the different alphabets, right, that makes up our DNA, A, G, C, T, if I'm not wrong. Okay, they must link with either G, they must link with another pair or another alphabet that is not their own. Okay, so they are not able to take anything that is similar to what they are. So A can only take GCT, G can only take ACT, so on and so forth. So in the case when A takes on A, there will be deformity, and this will be caused this we call this mutation. Okay, of course this is not biocast. If you want to read more, please go down to the link. Okay, and I'm not very good at this also. Okay, so yeah, let me just touch on the last 2 points. Oh yeah, before I touch on the last 2 points, there's this idea of the Geiger Mullah tube, which is somewhere here. Give me a moment. Okay, yeah, here. Okay, so the radiotherapy, right, it is derived from ionizing radiation. That means using this idea of ionizing radiation, it is to fight cancer cells. Okay, so yeah, like how I mentioned over here, how X-ray destroys cells but how fights cancer. Okay, yeah, please go and read it if you are interested. Okay, it may be tested, okay, depending on the kind of question. Now for EM wave, the question that they ask are more of application, and usually they would ask you things regarding under this column, the users. Okay, so first thing first, you need to know what are the users of the different type of EM waves. Second thing, there might be cases where they actually ask you how does it work. Okay, most of the time it's going to be related to ionizing or radiation. Okay, so yeah, now there's this thing called radioactive tracer. Okay, what it does is it measures how fast engines wear out. Okay, and it is to trace obstruction in oil, gas and water pipe. Okay, how does it do it? Okay, I'll talk about it in a while. Okay, detect leakage. These two, they are actually linked. Okay, so yeah, these three, they are, in fact these three, they are all linked. Okay, so what it does, right, is, let me zoom in more so I can bigger. Okay, change this, hold on. Okay, now, so what it does, right, suppose you have gamma ray. Okay, now gamma ray is produced by, say, some elements, some very radioactive element. Let's call it X, where X is a radioactive element. Okay, so now X is a radioactive element and it produces gamma ray. So let's say I have a pipe, right, okay, and the pipe is underground. So this is the pipe, and this is the ground, right? Or yeah, or rather this is the soil, right? Then this is where you are. So you suspect that somewhere in the pipe there is a leak. Okay, you suspect that the pipe is broken and now there's a leak here. Okay, so what you're going to do, you are going to introduce the element here, X, to go here. So as X goes down, right, okay, it's going to release gamma ray. Okay, let me denote gamma ray in this manner, gamma ray. Okay, so when there's a leak, okay, so let me just erase this because I'm going to add in some stuff. When there's a leak, okay, it's going to release gamma ray. This gamma ray will come up to the leak, okay, and because it has high penetrative power, it probably can escape to the ground. Okay, so what this person does then next, right? Okay, by the way, these are, let me just add in the word weak gamma ray. So what a person needs to do, right, is to somehow ask himself, how do I detect this? So to detect this, we use this thing called the GM tube. Basically, it is just something like a rectangular box with a digit counter here. So then we have this pipe here. This just for layman term, we just call it a receiver. Okay. Sorry. Now we call this the receiver. So what will happen is actually the gamma ray will actually go in here, and when gamma ray goes in here, right, this number will change. The number will change to say maybe 2, and it will continue to change. Okay, it may continue to change to 2, and then it will change to 8, 2, 2. There's a lot of gamma ray detected, and so forth. So the number changes. So greater reading means greater the radiation. So how does this actually help us find our leak, right? Okay, so now we go back to here. Okay, so now if we use the GM tube here, right, so this is the GM tube. Okay, now if we use the GM tube to detect the gamma ray, okay, and it actually counts something like, so it actually has a number like this. Okay, then we know, oh, gamma ray has escaped, then there must be a leak. Now in the case, so if now the reverse is true. So let's say the gamma ray is not being detected, right, and the gamma ray is not detected because let's say there's a protective layer here, and yeah, usually pipes that are underground, right, are made of strong materials such as metals of various density. Okay, so the gamma ray might not be able to penetrate through, so the gamma ray might come here. Remember, this is a weak gamma ray. Okay, so the gamma ray might come here and then gets reflected back. Okay, so it doesn't escape. So if there's, why is this so thick? Okay, hold on. Okay, so if there's no count, then there's no leak. Okay, so I'll end off here. Okay, tomorrow, yeah, tomorrow's test will be pretty simple. Okay, so wish you all the best. Yeah, please, if you're interested, go to the link below and check out certain things that we have discussed here. Okay, thank you for your time. Bye bye.